Can I get a hand who's using Uber? Wow, who used Uber today? Wow, so you understand what is Uber, and that's good. So today we're going to talk about Uber and what is fraud at Uber. We're going to talk about fraud detection and what we're doing to stop it. We're going to talk about specifically the project Radar Detect, which detects fraud, and Radar Protect, which stops fraud. And let's start from Uber. Uber is a global marketplace. It's a kind of like, imagine the country with 90 billion GDP. That's Uber. Last year, we completed about 6.3 billion orders. And as a system which facilitates all the orders, we take responsibility for the payment processing, which means if a driver or courier completed a trip, completed specific order, we have to pay them even if we cannot collect the money. And we'll see how it can happen. And imagine that if it's a $90 billion economy, if we lose 1% of the time, we lose $900 million. So fraud is a big deal, it's important. But fighting fraud, you might expect that we're going to have some massive ML system, massive neural net, which just makes decisions. So how do we stop fraud? Well, it's not enough. We have that. We have the systems which encapsulate and incorporate a lot of different behaviors which lead to fraud. But it's not enough. Our decisions need to be explainable. We operate in the real world. We work with real people. And if we stop someone from taking the trip, they literally can get stuck somewhere. And we need to make sure that we can explain why we didn't process this payment, we didn't process this trip. So explainability is very important. And if we look at the bottom, we have the team of risk analysts who constantly make decisions and create rules to stop fraud and put together the rules, what can go on the platform and what not. So, and the fact that we have risk analysts, we have all these rules, we have traceability of all our decisions. Every time some trip happens or doesn't happen, we know why. Let's think about how fraud can happen and what are the signals of payment frauds do we have. I'm going to tell you a real story, and it's about me. I literally took a ride to an airport, and while I was in the car, I got an email saying, oh, actually your plane now rerouted to San Jose. So I was going to San Francisco, I'm going to San Jose. Well, that's great. I mean, it was kind of strange, but I told my driver, hey, can you actually take me to San Jose? And the driver said, well, sure, yes, I can take you to San Jose. And he took me to San Jose. But what happened is the cost of my trip to San Francisco was about $15, and the cost of everything is about $60. So during the trip, the cost of the product which we sold, Uber sold to me, increased by 4 times, right? So what can happen? So imagine that if instead of me, there would be fraudster. And imagine that I put, let's say I paid with some prepaid card which had $15 on it, and we put authorization for $15, but then my trip actually costed $60. Uber would not be able to collect money. And that's what's called DNS, do not settle. When Uber cannot collect payment for the trip which happened. And a lot of times it can be fraud. Another situation can be chargeback. And so let's say instead of me, we would have a fraudster who was using stolen credit card. And they put this very expensive trip to 2 airports on this card. And then let's say the owner of this card comes back and says, okay, I never took Uber on that day, and Uber has to return this money. right? So this is, and this interactions, this is happening every day. So this is what we need to prevent. This is what we're dealing with. And in the bottom, you see this risk analysts. And before Project Radar, yes, we had all these complex models. Yes, we had very complex systems which stop fraud, but ultimately analysts need to make a decision. What is going to be the rule which stops fraudsters from taking these expensive trips and not paying for them? And at the same time, need to make sure that people like me don't get stuck in the wrong airport, right? So that's a challenging problem. That's why we need humans, and we need humans in the loop. So we spoke about fraud, and we spoke about the humans who stop it. So now let's talk about the systems in place we have which work with the humans to stop fraud. So what is Radar? Radar is a human-in-the-loop intelligence system which stops emerging fraud patterns, right? We already have the models which already been trained on most common behaviors. Most of this fraud can be stopped with models. But these new behaviors constantly emerge, right? Like, okay, there is one airport, there is another airport, let's figure out how to bypass the system. There is a new markets which Uber is expanding. There is a new payment systems. Uber, if you've seen a Super Bowl commercial, we not only deliver eats, but also Uber don't eat, and please don't eat that, right? So there is completely new behaviors which we never thought about. We don't have data on that. And we have this emerging behaviors which we need to stop. And first we're going to talk about Radar Detect, which is on top, right? So what we're doing is we're listening to the stream of payment processing results. We have very complex Uber payment system. We're listening to the payment results. We're getting the activity time series. We analyze it using the component which we built at Uber, different team called Uber Orbit. It's actually open source. You can take a look at it. And then we're prioritizing these notifications. And then this goes to analysts, and then further goes for Radar Protect to stop it. So let's see how it works, right? So this is the systems which we built in Uber, right? So Uber payment platform sends data to Kafka, and then it's a kind of classic Lambda architecture. We have a system called AthenaX, which is processing, which is basically SQL can work on top of the streams. It extracts the information in real time, which we need, and then using this Marmaray system to save all this data into our data lake. And at the same time, we have historical payment processing records. And this is what now we're going to learn why it's important, right? So imagine that. Imagine that when I took this trip, right? Imagine that actually I'm a good guy, but still my credit card declined because I might run out of money on this credit card, or this credit card is expired. So I'm as a good guy might have DNS, right? And what's going to happen? And I had it once, and then Uber sent me a message, said, hey, you didn't pay us, please pay. I paid, and I'm a good guy again, right? So the information, if we actually got paid for specific trip, did we get paid or not, comes later, right? So this is the ambiguity of our labels. When the data on is this trip good or not comes much later than trip actually happens, right? So that's why we look at the data in kind of two time dimensions. One time dimensions is when did we take a trip, right? So I took a trip, it was, let's say, Tuesday in the evening. Okay, that's order time. But then there is a payment settlement time. It might be that, okay, I might be a good guy who ran out of money on my credit card, and then a week later I paid. So the label came a week later. So we don't really know am I a good guy or the bad guy? Was it a good trip or bad trip for a week? The same thing happens to chargeback, because if I was a fraudster on the trip, the person who I stole money from didn't know about it for 2 weeks or for 1 week, and then they looked at their credit card statement, and they called and they took money back. So the data comes later. That's very important. That's why we have this PSMT second dimension, which tells us when the data when the labels comes in. And we have to work with these ambiguous labels to figure out if we need to act and what do we need to do. So now how do we detect the attack? So we use Uber Orbit to get this time series, and we're getting this time series from very granular segment from Uber, from different countries, different marketplaces. And we, in one shot, we doing time series decomposition, which gives us a lot of signals, and we figure out the pattern which gives us more or less actionable attack. So then, okay, so let's say you detected an attack, right? So what do we do with that? Can I get a hand? Who's got a mailbox full of alerts? I'm sure everybody who got full mailbox of alerts. So what I didn't want to do is to create another alert, because people not gonna care. People are not gonna open it. So what we're doing very judicial prioritization of this alert. So when we detect it, we have to do forecasting into how much we expect to settle and how much will not be settled. And after that, we prioritize based on this forecasted information, and then instead of sending another email, we use Jira to assign actual tasks to analysts to work on that, right? And this kind of feedback loop with prioritization and Jira helps us to have this cycle of human in the loop. So that's how we convert data insights into human action. So now let's talk about Radar Protect. So let's say we detected this attack is happening. Well, nothing is done yet. Nothing is stopped. So now we need to figure out the pattern of the attack. How are they doing it? What are they using it? Did they use some stolen credit cards? Did they found some bug in some application, or there is some version which is not working? So how do we do this? We use frequent pattern mining, and there is an algorithm called FP-Grows to help us detect these patterns of attack. But before we can start detecting the attack, what we have to do is feature selection, right? You can find enormous amount of patterns if you have a very kind of wide data. So we need to find the features which indicative of the attack. And there is a classic kind of feature selection algorithm called MRMR. It actually didn't work for us, but we kind of inspired by MRMR, and we used this process to bring some very specific filters for relevance and for redundancy. And this kind of insights came from understanding of our data set. So our data set is extremely imbalanced, right? So we actually used it to our advantage to see how to select the important features. And now let's talk about the core of the algorithm. How, I'm actually going to show here. How do we find patterns in data? So let's say we have two trips which we think fraudulent, right? We know that there is some features which lead to understanding that it's a fraud. And then what we're doing, we're kind of converting each feature value pair into its own ID. And then what's happening is we're getting the item sets, right? So each trip is converted to an item set. And then comes FP-Gross algorithm, which kind of became popular when the data scientists in Walmart decided to figure out, well, what is the most common patterns in the shopping carts of Walmart, right? And what they discovered is that the most common pair, which is unexpected, is that it's a beer and diapers. They never thought about, like, well, how beer and diapers go together, but apparently men run out of diapers, they run to Walmart, pick up the diapers, but also they pick up the beer, right? So this is the unexpected patterns which this kind of algorithm can help to discover. And this is the distributed algorithm which finds these patterns, and then we can convert this pattern, right? So here we detected this pattern, there's 3 key value pairs, which actually lead to the rule candidate. We found specific card bin, which is like part of your credit card number. We found the specific area code where fraud is happening, and we have the version. So now we are not done yet, right? Because FP-Gross finds a lot of patterns, and we're doing 2-level selection using percolation and then the rule candidates, and then we're doing validation on the whole data set. And then up with personalizing radar, right? So now before the analyst would have to kind of look at the broad range of data, try to find where the fraud is happening, and try to dig through a lot of data to figure out where is how to stop it. And now they're getting this global view where they see, okay, this is where fraud happens, and this is the pattern which you might use to stop fraud. And this is done through continuous kind of assigning tasks to specific analysts to work on. So, questions?